In this video, I'll be going over the skills that you need for multi-place predicate derivations. The only skills that we really need to update are how universal derivation and existential generalization work, which is what we're going to focus on in this video. At the end of this video, I'll do an example problem which makes use of both these skills and show sort of the hardest question that I can ask you in multi-place derivations. So here's an example of a predicate for all x, there exists a y. So I would know that I would have to UI this first because the universal is the main operator. And so UI is the sort of same operation. I ditch the quantifier and I replace all instances of the variable with whatever I want. So a perfectly legit universal instantiation would of course be to change x to, say, I don't know, f? No, let's pick d, okay? Because you can change it to anything. So I would have to change both instances of my x to this thing. And that's perfectly okay. But I also want to point out that you can also UI to operations. So I could UI to a of b. What's a of b? I don't know, the cousin of Bob? It doesn't matter. And in this case, what would happen is I would just have to preserve everything that is fixed. My second slot is still a of, except x here has to match. So I would UI as well to a of b because it has to be the same. And then I'd still have y. So this is also okay. So of course, once you realize this, you should see that you could UI to any sort of bizarro operation you want. It could be like d of a, e, f, g. Like, what's this? I don't know. This is just one operation. It's the d operation. And of course, I would have to put this exact same thing, structurally speaking, wherever there is an x, which is sort of annoying, but I'll just write it out anyway. F, G, and then I have y, and that's also okay. So universal instantiation doesn't change. You just have to know that it has to go to every single x if it's indeed an x, and you are allowed to UI to operations. Now I'm going to point out there is one thing you cannot UI to here. There is one letter you are not allowed to UI to, and that is you are not allowed to UI to y. So if you try to UI to y, you would have violated the capturing rule, which we've talked about. That you cannot do. So UI doesn't really change. Just a reminder, here's how it works on multiplace, here's how it works with operations. Okay, so staring at this, we also realize that existential generalization also has a lot of flexibility to it because of what we just learned for universal instantiation. So again, I'm not going to spend too much time on this because I know I have other videos on it, but what you can do for EG is you can pick any singular term, any singular individual, and generalize that, and you can also generalize as many instances of that same individual at the same time. So here are some legitimate existential generalizations. First, I could actually just do I. And so I could change all the i's to x, and that's okay. Now, interestingly, you don't have to generalize all of them. I could actually just choose to generalize, say, the first I, leave the second I alone, and for some reason generalize the third I. There's nothing wrong with this. This is perfectly consistent with how we know EG works. Okay, so that's okay. I could also generalize the entire A of I. So I could get something like, here, I'll change the Y now for no particular reason. I could get Y, BI, and then here I would get A of Y. And this is also good. So this is an important move. Here I chose A of I. And notice here, I just ripped out the A of I from within this third operation slot, and that's totally okay because I preserved the structure. It's still Y, A, Y. And that's fine as well. And of course, you could have left the A of I alone and generalized the B of I to Z, and you would still have A of I here. Okay, so that's all good. Let me just show you sort of a really common error. So some people will try and generalize and they'll get fx, bi, x. And this is no good. Because what they did for the generalize for the first x here was they changed a of I. But for the second x, they changed a of I And that's cheating because those are not the same thing. That's why you cannot do this one. Okay, so that bottom one, no good. Okay, so given those two things, we're ready to essentially do the tricky puzzle of multi-place predicate derivations, and it's not tricky at all. So here is my premise, and I want to show that there's this existential. So one, show there exists x, L, x, x, b, x. Lots of you would assume ID and quantifier negate. I'm just not interested in doing that. I'm never afraid of existential generalization. I'm just going to leave it for now. Instead, I'm just going to jump right to it. We know what line 2 is supposed to be. Premise 1 is an existential, so I immediately existentially instantiate, and I get for all y, L bracket b of I, y, b of y. Premise 1, EI. Okay, no problem. Now here's the trick. What I need to do is I need to UI y to something. But I need to UI y to something that ultimately I can generalize to and get this. Now this is a little too abstract. What we really need to do to make this clear is get some proof structure. And so what do I really want? If I want this existential, I want the following. I want L blank blank b of blank, where all these things are the same, because that's what it means to be x, x, b of x. Now, I like to call these things alpha. You do not need to call them alpha. If you want to, you can just leave them blank. Okay, so what do I have? Well, in terms of what I have line 2. So I have L of b of I, and then I have this y and b of y. But I'm not going to write y in. The reason why is because I know this y will change to anything I want from this universal quantifier. So I'm actually just going to leave it blank, but I can't leave the entire third slot blank because it's b of y, so I write b of blank. So I've stacked these on top of each other, and the trick is I can make these slots whatever I want so long as they are the same, because this will be the result of a UI from line 2. So this will say 2UI. That's how I'm going to get it. But I want to match the structure of what I want up here. So I want this structure up here so I can generalize. So this is actually just a simple puzzle. And it's a really simple puzzle once you stack them on top of each other. The reason why is because these predicates need to be the same. So the first slot has to be the same, their second slots have to be the same, and their third slots have to be the same in terms of structure. But once you realize that, the puzzle is clear. Look, the first slot is pinned in what I actually have to b of I. It's fixed to b of I. Which means if I want up here the structure alpha alpha b alpha, what do I immediately know that alpha has to be? In fact, I have no choice. Alpha must be b of I. So instead of having alpha alpha b alpha, what I really have is I want b of I, and this to be b of I. And that's the trick. So now I realize that what I have to UI to better make this thing in here b of I, and this to be b of I, and that's what I need to UI to. So the yellow highlight is telling me to UI everything to b of I, and now I get L, b of I, b of I, b of I. And this is line 2, UI to BI. Now the last step is to generalize. I will highlight to be crystal clear what I'm generalizing. I'm generalizing b of I here, b of I there, and b of I there, and I'm changing them all to x. And I get L, x, x, b, x. That is 3 existential generalization, direct derivation. So there's nothing to this. There's no new skills here. You've actually done puzzles like this already. It's just that never within a single predicate and never with operations. So I'm trying to show you that adding operations doesn't really matter, but it is really nice to do this sort of like stacking on top of things. So whenever you have some odd matching puzzle, which is typically the result of universal instantiation, and particularly when you need to do an EG or something like that, it's very handy to stack the predicates on top of each other so you can just sort of see how the slots are going to flow, and then it should sort of basically make it obvious what you're supposed to do from there.